Okay, so for this question, so what we're going to do is to look at question 1.1. So this is the application of symmetric property 1, which is basically a perpendicular bisector of chord. So earlier on, you have looked at symmetric property 1, which is the perpendicular bisector of chord. It says that if we denote the midpoint of AB as M, then chord here, right, a line passing through from the center, right, of the circle, right, it will cut basically the chord into two equal parts, right? So AM will be equal to MB. So that's what they mean by bisect. Okay, so bisect means to cut into two equal parts, and also OM will cut AB at 90 degrees. Okay, so that's why it's called a perpendicular, which means 90 degrees, and bisector, which is to cut into two parts, equal parts, right? So next, we look at question 1.1. Right, so the application of symmetric property 1, right, which is basically a perpendicular bisector of chord. Okay, so this is the perpendicular bisector of the chord, right? So we have AB and BC and CD, sorry, AB and CD to be the chords of a circle, right, where center O and with radius 9 cm. Now, given that AB is equals to 12 and radius is equals to 9 cm, right? Given that AB is equals to 12 and CD is equals to 10, right? We want to find the distance of O, right, from AB. All right, so after that, what do? Is we now look at, because this is perpendicular bisector, right? We know that, let's call this point AE, right? AE and EB will be the same, right? Which will say that if we just focus very hard on this triangle here, this is going to be a right angle triangle. AE over here will be equals to 6 cm, right? A is equal to 6 cm, right? So in fact, it's also equals to EB, which is equals to 6 cm. So that's something we can conclude, right? So AE equals to EB, which is equals to 6 cm, right? At the same time, we also know that angle OEA, right, angle OEA will be equals to angle OEB, which is equals to 90 degrees. All right, so over here, we can just write down our property, which we use. Okay, this is perpendicular bisector of the chord, right? So with that, let's look at this blue color triangle that you see, right? So if you see, if you just observe, right, okay, this OA, right, well, OAB, OA will actually be equals to 9 cm, because if we look at OA is also the radius of the circle, right? So if you look at this, right, what can we do now is we now can straight away use the Pythagoras theorem to find x, right? So if you look at this blue color triangle, this is 6, this is 9, and this is x. So x, by Pythagoras theorem, I can say that, you know, this x here would be the same as the square root of 9 square minus 6 square, which is equals to square root 45, right? So using your calculation, you can observe that this calculate would be 6.71 cm, right, to 36 feet. Okay, so part A, done, right? So the distance of OA, so just make sure you write down by Pythagoras theorem, right, by Pythagoras theorem, right? So this is part A. Okay, so part A is done. So next we will look at part B, right? So part B, we want to find angle OCD, which is over here. Angle OCD is over here. Let's call this angle Y. This is Y, right? So now, let me just erase all the other markings that I've done earlier. Okay, so if you look at OCD, right, again, I'm going to focus on this blue triangle here, all right? One thing I know is that because of the perpendicular bisector of chord, what is CF? CF is going to be 5 cm, which is the same as FD, which is also going to be 5 cm, right? So let me just write now, CF equals to FD to be 5 cm. At the same time, angle OFC is equals to angle OFD, which is also equals to 90 degrees. So all these are because we know the perpendicular bisector of chord, right? Perpendicular bisector of a chord. So sorry for the spacing, all right? So bisector of chord. So this also equals to 90 degree, right? So this wherever you see like a T shape, right? One line cutting through a chord, right, from the center, that this gives us straight away 90 degrees, and these two will be equal. So it's like a T shape or an inverted T, right? So from here, now we just observe this triangle here, right? So this triangle here, when we know about right angle triangle, we know that there are a lot of things that we can do. So one of the first things we can do is definitely Pythagoras theorem, and also Tuakaso. So just observe this, right? You can see that this part here will be the hypotenuse, this is the angle, and this part, that will be the adjacent, right? So we can use cosine, right? We can use cosine. So using Tuakaso, cosine y degrees will be equals to adjacent, which is 5, right? Adjacent over hypotenuse, which is 9. So y is equals to cosine inverse 5 over 9, and the answer turns out to be 56.3 degrees, 1 decimal place. All right, so that's all for question 1.1. Thank you.